3, 5. We are dividing polynomials. Dividing polynomials. So we're still on the same topic in this chapter of polynomials. Now, polynomial division, I'm going to need you to remember good old-fashioned long division, which you haven't done since, what grade is that? What grade would that be?
4 or 5.
4 or 5? You do long division. Okay, let's do long division so we can remember. So we got 977 divided by 3. We're going to do this like that. Remember that? Oh, I haven't drawn that in a little while. Right? We're going to put the 977 inside. Right? 977 goes inside. We're going to put the 3 out here. There you go. Right? I haven't done that in ages. Grade 4. Okay. So then, what we usually did was we said, how many times will 3 go into, and we looked at the first digit, right? So 3 into the 9, and we would say, how many times? 3. How'd you get that number? You went 9 divided by 3, right? So in your head, and then you would put that number over here. So 9 divided by 3, and you'd say 3 times. So in your brain, you go 9 divided by 3. Oh, I can fit it in 3 times. Then you would say, okay, you would say 3 times 3, and then you would write it underneath here. So 3 times 3, and you would write it underneath. And then you would draw your line like that. And then you would subtract. You remember subtracting? So 9 minus 9, so you would subtract. I'll circle that. You would subtract it, and you would say that equals 0. 9 minus 9 is 0. Then do you remember what you did? You would drag this one down and say, oh, I got another number to start with. And you'd go, okay, start it again. 3 goes into 7. How many times? 2 times. You would put the 2 here. 2 times 3, which would get me the 6. You would cycle back around and write it underneath. Okay? You usually drew a line, and then you subtracted again, right? Subtracted, you got your 1, and then you drag down again. The next column goes down. So 3 goes into 17, yep, 5 times. And then 5 times 3, cycle around, write it down. You're like, oh my gosh, can we do this forever? Minus it, right? So subtract. You don't have to circle the subtract. I'm circling just so you remember what I was doing. And then 17 minus 5, and I got 2. Did I try again? No, right? What did I do? I would stop, and what would I call this guy here? Remainder. That's my remainder. Remember that? Good times, good times. So that's my remainder. Now, I would also sometimes ask you, or elementary school teachers would ask you to write a multiplication statement to show you what you actually found. So your multiplication statement, so here, multiplication statement is this. Leave some room around here because I'm going to label a couple things here. So my multiplication statement, multiplication statement is, okay, we're going to go. I want you to start with the dividend. The dividend, okay, so the dividend is what you end up with. That's the 977. So this, I'm going to use blue here. That is the dividend. Dividend. That's your dividend. Okay? So I'm going to go 977 equals, okay, that's my dividend. Divisor, the divisor is the one doing the dividing. That's your divisor. You do kind of need to use these words because sometimes I'll say to you, can you tell me what the divisor is? And you're like, the what? That's the one doing the dividing, right? So the divisor is that one. So that would be the divisor, which is going to be 3 times quotient. Quotient is this guy here. Quotient. quotient. So the quotient is this end part here. Okay, so times the quotient, which is 325. You could use a bracket. You don't have to use a time symbol. And then plus the remainder. And my remainder is right here. So plus 2. So to check this answer, I would go 3 times 325 plus 2. That should equal my dividend. Dividend, I always think end. It's what do you end up with? 977. You end up with 977. Dividend, divisor, quotient is what you end up getting, and remainder. Right? So dividend is what you end up with. Divisor is the one doing the dividing. Quotient is what we get after we've divided, and remainder. Okay, so that's a multiplication statement. You have to know those words because sometimes I'll describe it. I'll say the divisor is this, the quotient is this, what is the, and then, yeah.
Didn't you also, like, if you wanted the decimal?
Oh, we're not going to go into decimals because the next thing we're going to do is we're going to divide with these guys. And so the decimals will end up being rational functions, so we'll stop there. Yeah, so good question is that we could have gone to decimals, but because we're going to go into polynomial division, we won't go into decimals. Yes, yeah, so we'll stop at the remainder. Yeah, so no decimals for us, we'll stop at the remainder. All right, so that's refreshing your grade 4 mind, and now we're going to do the same thing, but with polynomials. Right, so the same sort of actions happen. So this is called, there are 2 methods. The first one I'm going to look at is polynomial division. We're going to come back to synthetic in a minute after I finish these 2 polynomials. I'll show you what synthetic is and when we use it. How can you check it? You check your answer by expanding this, right? So if you have a multiplication statement, you expand it, collect, and you should be able to check your answer that it's right. Right, so you can check it by using your multiplication statement. So here, perform the following divisions and write your answers in this form, which is the multiplication statement. What do you notice? And we'll talk about what we notice. Yeah, and then I'll show you what synthetic is after. So let's concentrate on polynomial division, which is our long division right now, right? So that's what we are doing. So we're doing long division right now. Okay. All right, here we go. So first thing we do is draw that little cute little division thing. So we've got, I'm going to write it a little bit further left, not too far left, because I want a separate space for this guy. So I'm just going to separate it myself for a minute. Okay, just because I started writing mess here. So I'm going to go here. So I'm going to do kind of in the middle. There you go, give myself some room. And I've got x plus 2, so I'm going to put x plus 2 out here. Okay, I'm dividing, so that's the divisor. Dividend is what we've got here, so we're going to put the x squared minus 3x minus 10. Now, whenever you're doing division, I'm just going to point this out right now, you need to fill in the missing numbers. Now, if I was to give you, and I said that I want to divide 16 into 1,002. That would be 16, and I want to divide it into 1,002. Does that work? What do you have to do? What do you automatically always do? 0, 0, 2. Does that make sense? Okay. So when we divide in, we know that that's the thousands column, that's the hundreds, that's the 10, and that's the 1. Okay. When we're doing polynomial division, I need you to have them in order as well. You can't have x squared, x cubed, x, no x, right? So it has to be like this. We're doing this in order. Does that make sense? So if I gave you x to the power of, so say if I gave you x to the power of 4 plus 2x plus 5x squared, you go, that doesn't make sense. I can't do that, put that in my quotient thing, okay? You would have to go x to the 4, then, I'm missing x to the 3. So I would have to fill in 0x to the 3, then 5x squared, then 2x, and then 0. Does that make sense? I need all of the columns filled in. So the way we always did long division is that the columns have to match. It comes naturally when you're doing a number, right? I wouldn't leave off the 2 zeros. But when you have a polynomial, we usually don't write the ones that are zeros, right? And that's different than a number. Does that make sense? So always check. It's in descending order. So x and then 2. Here, this also should be in descending order. And if any of the columns are missing, I need you to fill in the 0 column. So x squared, x, nothing. Nothing to fill in. But does that make sense? So if I gave you something like this, it's out of order. I need you to put it in columns and fill in the zeros. Otherwise, long division just doesn't work, right? Because you're trying to line them up, right, with the columns, and it doesn't work. You're going to be trying to subtract an x from an x cubed, and you're like, that doesn't match. I'm like, yeah, because you don't have your columns matched up. Okay, so fill in the zeros where needed. Again, naturally with numbers, you never had to think about it, but you filled in zeros. Here, you have to do the same thing. Good? Okay, so fill in the zeros where needed. Here, I didn't need to. 1 squared, single, nothing. But you see they're both in descending order, right? I can't have one of them in ascending and one of them descending. It doesn't match. Okay, so here. The way we do it, it's the same way. We're going to say, how many times will, so here we said, how many times will 3 go into 9? We're going to look here. So I know that there's 2 terms, but I'm just looking at the biggest with the biggest. How many times will x go into x squared? And in my head, I go x squared divided by x. So I divide it, right? So in my head, I do this, and I go and I put it over here. Now, because I'm taking 2 columns, I write it on the second column. Okay, some teachers put it on the first column anyway. I say I'm grabbing 2 of them, so I write it on the second. It doesn't matter which way you write it. Like, I've just seen it taught 2 different ways. Again, I've been teaching since the cave walls, so in different ways. But so x squared divided by x, and I say x squared divided by x, right? X squared divided by x is x times. So I put it here. The reason why is because, look, when I multiply it, so I put that there. When I multiply it, so see how I did 3 times 3 and put it under? I'm going to do the same thing here. X times x, and I'm going to get x squared, x times 2, so 2x. So I line up my columns. So I put it above there. And again, I've seen teachers put it there, so it's the same thing, right? Doesn't matter which one. Okay. The next thing we did, so above, we said this times this, right? We went multiplication. You don't have to show that. And I wrote it underneath. Okay. Then the next step we did was subtract. Now, above here, I subtracted the 9. Here, I have 2 terms. It's polynomial, right? So I need you to put a bracket and subtract both. Okay? It's both terms. And if it's 3 terms, it's 3 terms. I could do the polynomial division with any number of terms. Okay? If it was subtracting 3, I would subtract all of them, not just the first. So I put a bracket, both of them. So x squared minus x squared is 0. It should always be 0. Why? Because I chose it. You divided it, put it down. It should always 0 out, right? There should be nothing left over. This one will always happen with the polynomial division. You took it, divided by x, you wrote it down, so of course it's 0. Okay, then these two, negative 3x minus 2x, negative 5x. And then what did we do? We dragged down this next column to get my second column, minus 10. And now I have 2 again. It's lined up. So how many times will, okay, so let's try this again. How many times will, I'm going to use blue. Does this show up? Is that okay? Right, so how many times will negative 5x, you divide this one by x. Negative 5x divided by x is negative 5, and you write that here, minus 5. You don't have to show that, but that's how I got the number. And then multiply it. So you go negative 5x. Look, it matches, and it should match. You chose that number. It should be exactly the same. That times that. The second number, negative 5 times 2, negative 10. Then we subtract both of them. What do I get when I subtract? 0, negative, negative, negative 10 minus minus 10, 0. All gone. 0 plus 0. So no remainder, right? So no remainder. That's what that means. 0, right? No remainder left. So when I write my multiplication statement, which I asked you to do up here in the question, right? So I want the dividend, right? So I'm going to say x squared minus 3x minus 10 equals the divisor, which is x plus 2, times the quotient, right? X minus 5, and look, no remainder. So don't put plus or minus anything because there's nothing there, right? So nothing goes there because nothing goes there. So you don't have to put plus 0, just it's nothing there. So people are like, what do I put? Nothing, because there is no remainder. Okay. I asked you what you noticed. I said, what do you notice? So above I said, what do you notice? If the remainder is 0, what did I just find? Yeah. Factored form. So we're going to use this later on to factor the other stuff that we did. I'm going to have expanded form. We're going to factor it. We're going to say, does it order of 2, order of 3, and graph it. So we're going to go backwards and forwards. So we should be able to factor using this. If the remainder is 0, it's a factor. That's actually a theorem that they developed. If it's a factor, the remainder's theorem, and if the remainder's 0, if the remainder's 0, then it's a factor. So they went, that's so cool. So I know if the remainder's 0, I know it has to be a factor. And they developed a whole theorem about that. We'll talk about that later. Okay, so then we know if the remainder is 0, then x plus 2 is a factor, right? So if I found that the remainder is 0, I saw that x plus 2 is actually a factor of it. It factors right in beautifully. So that's a really cool thing to notice, and they developed a whole theorem about that. We'll use it later on. Okay, let's try it again. Let's try it again. We're going to do polynomial. So let's write our polynomial here. Kind of put it in the middle. Okay, not too far. And then we're going to go x plus 2 goes out here. X squared minus 7x minus 10. Squared, single, nothing. Just make sure the order is good. It's an x and a 2. So the order is in descending order for both. No zeros to fill in. All right. So then we are going to look at the first and the first. So I looked at the first term and the first term. So again, x squared divided by x got me x. That goes here. Right, first one divided by first. The biggest divided by the biggest. Then I multiply it. So I'm going to get x squared plus 2x line. So x times both of those. You put it there. And we're going to subtract minus both of them. X squared minus x squared, that should be 0. It should be because we chose it to be so. Negative 7 minus positive 2. Negative 9x. Okay, I want two terms here, right? Because that first one goes into the first one, so I need to drag down the second one. So I have two terms into the two terms again. On the side, you don't have to show this, but it's negative 9x, the first divided by the first. Negative 9x divided by the x gets me negative 9. Okay, multiply, so it does this circle. Negative 9 times x is negative 9x. Negative 9 times positive 2, minus 18. Line. Subtract them both. Negative 9 minus minus, so that should be 0 as we chose it. This becomes negative 9, negative 10, watch your signs, right? Negative, negative, so 8. Plus 8, my remainder is 8. You don't have to put the plus 8, you just put 8, 8. Okay, that is my remainder. So if you're writing your multiplication statement, you always start with the dividend, right? So x squared minus 7x minus 10 equals divisor, which is the x plus 2, quotient, which is the x minus 9, and then this time I do have a plus 8 remainder. And that tells me it doesn't divide nicely in, right? It's not a factor. I tried dividing x that by x plus 2. X plus 2 is not a divisor, right? It's not a factor, I mean. It is a divisor. Okay, so it's not a factor because I got a remainder. Right, so sometimes there'll be a remainder, sometimes there won't be. It's a cool theorem, and we'll use that theorem later on. Next, I'm going to show you synthetic. Okay, don't turn over yet. I'm going to show you on this one. I'm going to do it rough. You're not going to copy it. You're just going to watch with me, and then I'm going to do it again with you on the next page. So stay here for a second. I'm going to do some covering up. Okay, I guess I'm going to start the video again.